Hello everyone, today we'll be looking at some quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2019 Test 5A Paper 1 Code A and B. So let's start with the first section. This section contains 8 questions. The answer to these questions is in the form of single digit integer. So let's start with question number 21. 8.15 gram of BaMnO4 whole twice sample containing inert impurity is completely reacted with 100 ml of 11.2 volume H2O2 in the acidic medium. The percentage of the impurity present in the BaMnO4 whole twice sample is. So we have to report the percentage to the nearest integer. The molar mass of BaMnO4 whole twice is given to us. So if we talk about the H2O2 sample which is given to us. So it is given to us that the volume strength of H2O2 is equal to 11.2. So if we talk about the normality can be found out by dividing this 11.2 divided by 5.6. So which will give us a value of equal to 2 normal. Now if we talk about the MEQ of H2O2, so that shall be equal to 2 into 100, which is equal to 200. Okay. Now we can equate the MEQ of H2O2, which we have just found out, to the MEQ of BaMnO4 present inside the sample. So we have MEQ of H2O2 is equal to the MEQ of BaMnO4 whole twice. So we have 200 on the left hand side, and if we assume that there are X grams of the BaMnO4 whole twice present in the sample, then the moles can be found out. We have to divide it by the molar mass. And now we have to find out the N factor. The N factor of BaMnO4 whole twice is equal to 10, as there is Mn present in a state of plus 7, and Mn plus 7 converts into Mn plus 2. So for each Mn, there will be a gain of 5 electrons, and there are 2 Mn present inside the compound. So we have the N factor equal to 10, and also we're dealing in terms of MEQs on the left. So we have to multiply this by a factor of 1000. So if we try and simplify this expression for the value of X, we have X is equal to 7.5 grams. So students, we can see that out of the 8.15 gram sample, 7.5 grams is of BaMnO4 whole twice. So this approximately comes out to 92% of the sample. So if we talk about the impurity has to be around 8%. So students, for this question, we have to mark the answer as 8. Let us look at the next question. Question number 22. Glass is typically metastable, and these metastable structures are prone to convert into a more thermodynamically stable structure. Suppose a crystalline glass, which is already in the BCC structure, has tendency to get converted into N-centered cubic structure. The activation energy required to initiate the process is 11488 joule per mole at 300 Kelvin. So we have to calculate the ratio of the number of N-centered cubic unit cells to BCC unit cell after a time interval of 0.23 hours. So it is given to us that the reaction follows first order kinetics. So some additional information is given to us which will be required for solving this question. So we have been given that the pre-exponential factor is equal to 1000 R inverse. The value of R and the conversion of ln to log is given to us. Okay. So let us first try and figure out the rate constant K. So K shall be equal to A into e to the power minus EA upon RT. So if we take ln on both sides, we have ln K equal to ln A minus EA by RT. So we can have ln K is equal to 2.3 log of A minus EA by RT. So if we talk about the A value is given to us, it is equal to 1000, and the EA value we had already seen, EA is equal to 11488. The value of R is 8.314, and the value of temperature is equal to 300 Kelvin. If we put these values in the expression, we have 2.3 into log A shall be equal to 3 minus 11488 upon 8.314 into 300. So this term on simplification gives us a value of 2.3 into 3 minus 4.6. So now we can convert this ln k into log k. So we have 2.30 log k shall be equal to this term, and log k will simplify to be equal to 1, which implies that the value of k is equal to 10 R inverse. Okay. So now we can have the first order kinetics. So we have ln of a naught by at is equal to k into t, and we are dealing with the reaction in which the BCC converts into the ECC, the end-centered cubic. Okay, so we can have the values. The value of k we have just found out, it was equal to 10. The time given to us is 0.23 hours. And if we convert the ln into log, we have 2.3 log of a naught by 80. So this on simplification gives us a value of a naught by 80 is equal to 10. So which means that if we had 10 BCC units initially, only one BCC unit is left finally, which must mean that the number of end-centered cubic unit cells formed is equal to 9. So after time equal to 0.23 hours, we have 9 end-centered unit cells, whereas if we talk about the body-centered unit cell, it is only 1 in number. So the given ratio comes out to be equal to 9:1, and we have to mark the answer to this question as 9. Let us look at the next question. Question number 23. How many planes are possessed by NiCO4 molecule which divide the molecule into two identical parts? So students, we have to talk about this complex which is NiCO4. So Ni is present in a state of 0, which means that it has S2D8 configuration. Now CO is a strong field ligand, so it will cause pairing, and the rearranged configuration shall be S0D10. So we can see that it has no vacant d orbitals, so the complex has to be sp3 hybridized, which must mean that the complex is tetrahedral. Now if we talk about the number of planes of symmetry in NiCO4, the plane of symmetry shall pass through any two CO molecules. So we have 4 CO molecules, and out of that we have to select any two, so which will give us a value of 4C2, and that shall come out to be equal to 6. Students, for this question we have to mark the answer as 6. Let us look at the next question. Question number 24. How many tautomers of the compound are possible? So we have to exclude the optical isomers, and we have to assume that at a time only one carbonyl group forms the enol. So let us try and draw the tautomers of this structure which is given to us. So we have this structure. Now we have two carbonyl groups in this compound, and we can have tautomerism around both of these carbonyl groups. So let us first have the case where this carbonyl is taken into consideration. So there will be two cases of the enols formed. Let us try and draw them. If we make the double bond on the left, we're going to have the formation of this structure. And if we have the double bond on the right, we're going to have the formation of this structure. Now, if you look at the second compound which is formed, it shall be able to show geometrical isomerism. So there can be cis-trans isomerism shown by this enol form. So both of them have to be counted. So we're going to have a total of 3 enol forms if we talk about the double bond formation with the carbon on the left hand side. Okay, we can now have cases where the double bond will be around this carbonyl group. So we can have one on the left and we can have one on the right. So let us discuss those cases. So we're going to have the formation of this enol, and we're going to have the formation of this enol as well. Now if we talk about the enols which are derived from the cyclic carbonyl compound, none of these two enols can show geometrical isomerism. So if we talk about the total number of enol forms that are formed, we're going to have a total of 5 structures for this substrate which is given to us. So students, For this question, we have to mark the correct answer as 5. Let us look at the next question. Question number 25. How many of the following ion in octahedral complex have equal value of crystal field stabilizing energy with strong field as well as the weak field ligand? So we have to ignore the pairing energy. Students, if we talk about this question, we know that the configuration, electronic configuration will be same for D0 to D3 and D8 to D10. So in this case, the electronic configuration remains the same in presence of weak field or strong field ligand. So the examiner seems to be interested in these cases. So they should either be from D0 to D3 or from D8 to D10. If the configuration lies from D4 to D7, they have different configurations with the ligands. Okay. So if we talk about the species which are given to us, we have been given Mn plus 2 and Mn plus 3. So Mn has a ground state configuration of S2D5. So if you talk about Mn2 plus, it will have D5 configuration. And if you talk about Mn3 plus, it is going to have D4 configuration. If you talk about Fe, so both the ferric and the ferrous ions have been asked by the examiner. So Fe in the ground state has S2D6 configuration, which means that Fe2 plus will be D6, whereas Fe3 plus will be D5. And if we talk about Cr2 plus, Cr in the ground state has S1D5 configuration, so Cr2 plus is going to have D4. And if we talk about CO3 plus, so CO in the ground state has S2D7, so the plus 3 form of cobalt is going to have a D6 configuration. Now students, in all of these cases which are given to us, we have the configuration belonging to this range. So these ions we had already seen before that they have different configurations in presence of weak field or a strong field ligand. And for this question, we have to select the answer as 0. Let us look at the next question. Question number 26. Consider the following unbalanced redox reaction. So we have Hg2 plus and NO3 minus reacting to give us Hg2 plus and HNO2. So the concentration of the ionic species at equilibrium are given to us. If E0 cell of the reaction is 0.09 volt, calculate the minimum pH required to reach equilibrium. So we have been given the conversion units. So 2.303 RT by F has to be taken as 0.06, and the value of log 2 given to us is equal to 0.3. So if we try and talk about the reactions which are happening inside the given cell, so we have Hg2 2 plus converting into Hg2 plus. So oxidation is taking place here. So this will be the anodic reaction. So if we talk about the balancing, we are going to have the formation of 2 Hg2 plus there will be loss of 2 electrons. If we talk about the cathodic reaction, we have the nitrate ion converting into HNO2. So we can have the balancing for oxygen first. We'll have H2O and 3 H plus ions on the left in order to balance the hydrogen atoms. And if we talk about the charge balance now, we have to add 2 electrons on the left hand side as well. So if we talk about the overall reaction happening, we have Hg2 2 plus NO3 minus plus 3H plus giving us 2 Hg2 plus HNO2 plus H2. Now the concentration of these species have been given to us. Hg2 2 plus is 1 molar, NO3 minus is 1 molar. This we have to find out. Hg2 plus is also 1 molar, and the concentration of HNO2 given to us is also 1 molar. Okay. So if we talk about the Q, the reaction quotient for this equilibrium, we're going to have the value as Hg2 plus whole square into HNO2 upon Hg2 2 plus upon NO3 minus upon H plus whole cube. So all of these species apart from H plus ion concentration have been maintained at 1 molar. So all of these values are equal to 1. So they'll cancel out. And the value of Q shall come out to be equal to H plus ion concentration raised to the power minus 3. Now we can apply the Nernst equation in this question. So if we apply the Nernst equation, we are going to have E cell equal to E naught cell minus 0.06 upon 2 into log of Q. Now it is mentioned to us that the reaction is at equilibrium. So if the reaction is at equilibrium, it will mean that the E cell value is equal to 0. So we're going to have the value of E naught cell equal to 0.03 into log of Q. Now if you put the value of E naught cell, it is 0.09. It should be equal to 0.03 into 3 times the pH value. So if we talk about the pH value, the pH shall come out to be equal to 1. So the pH at which this reaction will be at equilibrium for the given concentration of the ions or the products, we can see that the pH has to be equal to 1 in this case. So students, for this question, we have to mark the answer as 1. Let us look at the next question.